Okay, so we're going to expand on what we were doing the other day, which is proving statements about angles, segments, algebraic, all that stuff we were doing the other day. We're just going to expand on it some more. Some of this is a little bit of a repeat of what we did the other day, so I'll go kind of quick through the first part. All right, the essential question, how can we use algebraic properties to prove mathematical statements? All right, so we're going to be writing some more two-column proofs. We're going to name and prove congruence, properties of congruence, and we're going to just take a quick look at flowcharts and paragraph proofs. Not my favorite proofs, so we're not going to spend a whole lot of time on them. All right, so here we go. Reflexive property, remember, is when something is equal to itself. So it's like a reflection. So a reflection. And then symmetric is just when they switch places, so they just move to the opposite side. Then transitive is when you have three pieces. If A equals B and B equals C, then these two cancel out and you're left with what's left. All right, so if measure of angle 6 equals the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. That is symmetric. If 34 degrees is equal to 34 degrees, that is reflexive. And if the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 5, well, since angle 2 is equal to 1 and 5, then they are congruent to each other by transitive. All right. So let's look at reflecting a beam of light off of a mirror. So we've got these two angles. So you've got the measure of angle DBA is equal to the measure of EBC. So DBA is this whole angle here, while EBC is this whole angle over here. So notice they both have an angle 2 in them. So we want to prove that this angle is congruent to this, or we know this angle is equal to this one because it's what's given to us in the picture and stated. They want me to prove that DBA, so the red angle, is equal to EBC, which I labeled as the green angle. All right, so first thing is always what's given. So there's your reason, given. The measure of DBA, so the measure of DBA, which is the red angle, this is the one I marked as red. So I will do, oops, let's start over. So DBA would be this one here. So that's going to be the measure of angle 3 plus the measure of angle 2. So that would be our segment addition, or sorry, angle addition, which is like the segment addition. And since 1 and 3 are equal, I'm going to replace the 3 with 1 by substitution. And since DBA is equal to 1 plus 2, and I know 1 plus 2 is equal to EBC, because that's angle addition. Well, since this one is equal to this one, then these two are equal to each other by the transitive property. So I just proved that the red labeled angle and the one over here, which is green, are congruent. Okay, so again, reflexive, if something's equal to itself, it's reflexive. If they just switch places, then it becomes symmetric. And if you have one thing that's equal to 2, then those two are equal by transitive. So if T is congruent to V, V is congruent to R, then T is congruent to R by transitive. All review from last time. Okay, so let's just write some proofs now. All right. They're telling me that line K and line L bisect each other. So since they bisect each other, that means they cut each other in half. So they're bisecting each other at point M, and they're telling me that BM is congruent to CM. Well, if this is the midpoint of both line segments, then all 4 pieces are congruent. they want me to prove that AB, the whole thing here, AB, is AM plus DM. So the length of AB is the same thing as this piece added to this piece. So we're going to walk through and prove that. So first things first, write down what's given. BM is congruent to CM. Well, I know that CM, I know this piece is congruent to DM because that's a midpoint. So that would be definition of a midpoint. BM is congruent to DM. Well, because if this piece and this, if this one piece is equal to these two, then those two are congruent by the transitive property. And if you'll remember, anytime you go from being congruent to equal or equal to congruent, remember they are interchangeable. So that is the definition of congruence. So that would be the definition of congruence, or the definition of congruent segments. Segment addition. Well, I know that AB, the whole thing, is equal to AM plus BM. So the whole thing, AM plus BM. Well, if I replace, if you'll notice you have your AB stayed the same, your AM stayed the same. But since these two are equal to each other, then I can replace it by substitution. And then that is what they wanted me to prove, is that this segment here is congruent to this piece plus that piece. And we will elaborate on this some more in class. So if you're not feeling it yet, just keep going. Okay, this one says angle AEB, so AEB, that would be this angle right here, is the complement of BEC. Well, if they're complements, remember, what does that mean? That means that they add up to 90. So since that's what's given, I have the statement and reason given. Well, if AEB is a complement, then that means if I add them together, I get 90, because that's the definition of complementary, two angles that add up to 90. The next thing we have is AEC. So AEC is the whole thing here. And that's going to be equal to AEB, which is this piece, plus this piece. So that would be angle addition. Well, I know that AEC is 90 because that's the definition of a right angle. And now I know that if AEC is 90, so if this is 90, then this one over here is 90, or not necessarily 90. I know that, let's back up a little bit. I know that this one is 90, but I know that this one plus this one is a linear pair, so I know they're supplementary. So they're going to add up to 180. And I know, oops, I know that AED plus 90, because remember AEC is 90, we proved that right here. We said that AEC was 90, so I'm going to replace AEC with 90. So that was substitution. And I'm going to subtract the 90 from both sides. So if I subtract it from here and from here, I'm left with AED equals 90, which is what they wanted me to prove. And I use subtraction. So just think about, where are we headed and what are we looking for? All right. This is a flowchart proof. I really don't care for these, but I have to introduce them to you. So basically what happens is you're given that angle 1 and angle 2 are right angles. So that's given. So angle 1 and angle 2 are right angles. It's given. Then because they're right angles, that means they are equal to 90. So measure of angle 1, measure of angle 2 both equal 90. That's the definition of right angle. Since they're both equal to 90 degrees, then they're equal to each other. And that would be transitive because I've got 90 degrees equal to two things. And since the measures are equal, then the angles are congruent by definition of congruence. And I need to put my little congruent mark there. And that's basically a flowchart. It's the same thing as a two-column proof. I think the two-column proof looks neater and is easier to follow than a flowchart. The other kind is a paragraph proof. Same thing, it's just like making statements. Again, a two-column proof is so much easier to follow. So over here in this picture, we've got angle 5 and 7 are vertical. So if angle 5 and angle 7 are vertical, then that's what's given. Okay, angle 5 and angle 7 are vertical angles formed by intersecting lines, as shown in the diagram. Angle 5 and angle 6 are a linear pair. So, So angle 5 and angle 6 are a linear pair. So those two are a linear pair. And angle 6 and angle 7 are a linear pair. So now angle 6 and angle 7. So now these two are a linear pair. So that would be my next thing. Those two are linear pairs. That's the definition of a linear pair, as shown in the diagram. Okay. Then, bilinear pair postulate, 5 and 6 are supplementary, and 6 and 7 are supplementary. So 5 and 6 are supplementary, and 6 and 7 are supplementary. I forgot to add the 6 and 7. Let me get that in there now. So you might want to add here, comma, angle 6 and angle 7 are supplementary. Just copy that again, but put 6 and 7 in there. Sorry about that. And since 5 and 6 are a linear pair and 6 and 7 are a linear pair, by the linear pair postulate, 5 and 6 are supplementary and 6 and 7 are supplementary. So by the congruent supplements theorem, 5 is congruent to 7. So if 5 and 6 are supplementary and 6 and 7, then that must mean 5 and 7 are supplementary. And that's the congruent supplements theorem. Again, this is so much easier to follow than up here, but they still have your reasons. They're still listed in here, linear pair postulate, given, it's all still there. Two-column proofs, that's what we're going to be working with. All right, so now, using the diagram and the given angle measure, find the other three angle measures. So if angle 1 is 117, then I know angle 3 is 117 because they're vertical, and vertical angles are always congruent. 1 and 2 make a line, so these two are a linear pair. So 180 minus 117 is 63. So this one's 63, therefore this one's 63. And there you go. All of them right there together. All right, next. Find the value of W. Well, again, the information that's given are linear pair, or sorry, are vertical angles. So because we have vertical angles and vertical angles are congruent, then that means these two are congruent to each other. So 5W plus 3 is 98. If I subtract 3 from both sides, I get that 5W. So if I subtract 3 from both sides, 5W is 95. Then if I divide both sides by 5, I get that W is 19. Okay, and number 12. Again, we have intersecting lines, so we have vertical angles. So this one is congruent to this one. So 4x equals 6x minus 26. If I subtract 6x from both sides, I get negative 2x equals negative 26. And if I divide both sides by negative 2, I get x is 13. And with that being said, that means these two are vertical and congruent to each other as well. So anytime you see intersecting lines, you should automatically think, oh, I have congruent angles. So 7y minus 12 is equal to 6y plus 8. If I subtract 6y from both sides, I get y minus 12 equals 8. And if I add 12 to both sides, I get that y is 20. And we found the values, and that's all they wanted me to do. If I needed to, I could plug it back in. So I could do 4 times 13, which would be 52. So that would mean this angle was 52 degrees. So that would mean this one was 128, because these two would have to add up to 180 to be a linear pair, which would make this one 52 and this one 128 as well. So they only asked me to find X and Y, but now that I found it, I can actually find the measures. All right, so that's it. Try to keep them short and sweet. Hope you had a great weekend, and I'll see you later.